lecture example number 4 says that 3.5 grams of copper react with 6.0 grams of silver nitrate. Identify the limiting and excess reactant. On the PowerPoint or the presentation, right, it's Google Slides, it shows the equation. It might be balanced, might be not. So, copper reacting with silver nitrate, and that's going to yield, now copper, since it is a transition metal, it could go 2 plus or 1 plus. It's going to be 2 plus in this situation. We're going to go silver, single replacement reaction, plus CuNO3 2. To balance that, we are going to we'll need 2 nitrates on the reactant side, so 2 there. That leaves us with 2 silvers, so that would be a 2 there. So the balanced equation tells us that 1 mole of copper will react with 2 moles of silver nitrate, making 2 moles of silver and 1 mole of copper 2 nitrate. And oh, how wonderful life would be if we just had moles and we had to figure that out. But it tells us that we are reacting 3.5 grams of the copper, and we are using 6.0 grams of the silver. It asks us what's going to be the limiting reagent and what's going to be the excess reactant. To determine that, now there are about 50 different ways that you could determine what the limiting and what the excess reactant is. I think the most simple and straightforward way and the least confusing to students is that you use each of the reactants to determine how much product you're going to make. The one that makes less product is the limiting reactant. The one that makes the more product is the excess reactant. I have 2 products. I could choose silver or I could pick copper 2 nitrate. Doesn't matter. Both would tell me what the limiting and what the excess reactant are. I'm going to look ahead in the question, and further on in the question, so part B asks, how many grams of silver are produced? Well, since later I'm going to have to figure out how much silver is produced, I might as well use silver now as my determination of what's the limiting and what's the excess, and that'll save me some time later. So first, if I'm starting with grams of copper, I need to convert that to moles of copper, because moles of copper relates to moles of silver. Moles of silver I can then convert to grams of silver for part B when I need to do it. So we're going to multiply it by 1 mole of copper for every, what is it on the periodic table? 63.55 grams of copper. Then we're going to convert that to moles of silver, and we need to cancel moles of copper. Moles of copper go on the bottom, and it's 2 moles of silver for every 1 mole of copper. So it's a 2-to-1 ratio. And when we punch that in our calculator, 3.5 times 2 divided by 63.55, we are going to get 3.5 divided by 63.55 times 2. 0.110149 moles of silver. And now we'll do the exact same calculation, but with grams of, oh my, it's silver nitrate. Glad I caught that. If we determine that 6 grams of silver nitrate makes fewer moles of silver, then that's going to be the limiting reactant. If we find that 6 grams of silver nitrate makes more moles, then that means silver nitrate is our excess reactant and that copper is the limiting. We'll multiply it by 1 mole of silver nitrate for every so many grams. We can kind of tally it up over here. So silver is 107.87, nitrogen is 14.01, and then there are 3 oxygens, each at 16.00, so that would give us 48.00, and we got all those from the periodic table, right? So good there. Tallied those up, and it comes out to be 169.88 grams for every 1 mole. You can check that, but I'm pretty sure that's right. 169.88 grams of silver nitrate is equal to 1 mole of silver nitrate, and then we will convert that. It's a 2-to-2 ratio. There's 2 moles of silver for every 2 moles of silver nitrate, and so we'll do that math. 6 divided by 169.88. No, then times 2/2, so that's just the same deal. And it is 0.035319 da 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 da. This is smaller. So that means silver nitrate is our limiting reactant, and that copper is our excess reactant. How much silver are we going to make? Well, we're going to make 0.035319 moles of silver. Part B asks, how many grams of silver is that going to be? Well, that's a pretty simple conversion if you know moles. So I think there's just enough space down here that we can work that out. So we will take our 0.035319 moles of silver times, and it is 107.87 grams of silver for every 1 mole of silver. And you multiply that, and we get 3.809865. Looking back to the original problem, 6.0 was 2 sig figs, 3.5 was 2 sig figs. This whole problem is just 2 significant figures, so we are going to round that answer to 3.8 grams of silver. Yeah, you can read that. Okay, pretty much. All right. Let's organize our thoughts just a little bit. We saw that we took 3.5, was it 3.5? Grams of copper. We reacted with 6.0 grams of silver nitrate. Initially, we had 0 silver and 0 copper nitrate. So those are all of our initial amounts. When we end this process, we just saw that we would create 3.8 grams of silver. And since silver nitrate is the limiting reactant, we're going to use all of it, right? If you use all of the silver nitrate, the most silver that you could possibly make is 3.8. So if I make 3.8 grams of silver, I have completely consumed my stock of silver nitrate, and that would mean there are 0 grams of silver nitrate. Copper 2 nitrate, there'd be some amount, right? Because it's the other product, and whatever it is, I don't really care about it because no questions asked about could we calculate it? Oh, definitely we could calculate it. Nobody cares, so we're going to ignore that for right now. Now, copper, on the other hand, we said that it was the limiting reactant. So it could make more silver than 3.8 grams, but not by itself. It has to have silver nitrate to react with. So some amount of this 3.5 grams of copper is going to be used, but I don't know how much, right? So at the end, there will be more than 0 of the copper, but less than 3.5 because I'm going to use some portion of it. So I need to figure out this. I need to figure out how much of the copper was used. If I figure out how much copper was used up, then I can subtract that from how much was there at the beginning, and the initial minus the amount used would equal how much is left over at the end. What I'm going to do is I'm going to figure out how much copper would be needed to make 3.8 grams of silver. So I can figure out that used amount, right? The amount of copper needed to make 3.8 grams of silver. That's going to be my amount that was used of my 3.5 that was available. Subtract those, boom, I have the amount of copper that remains at the end of the problem. We're going to take 3.8 grams of silver. First, we got to convert that to moles of silver. So times, and it's 1 mole of silver for every 107.87 grams. Then we're going to go from silver to copper. So it is 1 mole of copper for every 2 moles of silver. Moles of silver divide away, grams of silver divide away, and now all I have to do is figure out grams of copper. So grams of copper for every 1 mole of copper, and I look on the periodic table, and copper is 63.55 grams, so we got 63.55 grams. Moles of copper divide away. Multiply across the top, divide across the bottom, and I get 3.8. I got 1.193563 blah 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 blah. 2 sig figs, gonna round my answer. 2 significant figures. So that's going to leave us at 1.1 grams of copper. 1.1 grams of copper comes up here, 1.1 grams, and then at the end, 3.5 minus 1.1. I don't even need the calculator. It's going to be 2.4 grams. So at the conclusion of this, I would have 2.4 grams of copper remaining, and that was my excess reactant.